Right, grade 12s, in this lesson what I want to do is revise your grade 11 circle geometry theorems. These come up a lot in your matric geometry. So let's look at the first theorem. If you remember carefully, what did it say? It said the line from the center to a chord does something. Okay, now the trick is if AM is equal to MB. So if AM is MB, then immediately you know that those two angles M1 and M2 would be 90 degrees. These two would be 90 degrees. So going this way says if AM is equal to MB, then these two angles are 90 degrees. If you go the other way, so if you say if M1 equals M2 is 90, we get what we call a converse theorem, which says if those are 90, then these two, AM is equal to MB. Okay, so that was theorem 1. Okay, have a look at the second theorem. Now have a look. This is the angle at the center is twice the angle at the circle. So what it's really saying is if you've got an arc AB, look at that, an arc AB, and it tends or forms an angle at, look at that, it forms an angle at the center and an angle at the circumference. And what we know is that the angle at the center is double the angle at the circumference of the circle. Angle at center is 2 times the angle at the circle itself. So if x was 30 degrees, then obviously O1 would then itself be double that, which is 60. Now remember, angle at center is twice angle at the circle. Now another variation of this theorem, if you remember, if there's your arc, okay, there's your arc there. Arc AB is forming an angle at the center, and the same arc forms an angle at the circumference. And the angle at the center, that angle C, or the angle O1, is double angle C there. Okay, so that is going to be angle at center is twice the angle at the circumference. Now what if your arc is pretty big? Have a look at this one. This is tricky. If you remember grade 11 days, you had a big arc here. And let's see what it's going to do. There we go. So let's have a look there. We've got the arc here. So this whole big arc here is subtending an angle at the center, an angle at the circle. So if x is 120, O1 would be double that, 240. So watch out. So this whole arc here, this big arc here is forming an angle at the center and an angle at the circle, and the relationship is that the angle at the center is double the angle at the circumference of the circle. Okay, cool. Now what about this one? If you look at this, if this is a diameter, then look at your arc is subtending an angle of 180 degrees at the center, which means that the angle at the circumference is 90. So what they say that the angle in a semicircle is 90 degrees. Okay, that's the other theorem. What about angles in the same segment? Look at this arc here. Now take that arc there. What is it doing? It subtends an angle at the circumference, and it also subtends a different angle, another angle at the circumference. And these two angles here are actually equal. Okay, and likewise if you take arc DC, it forms two angles, and those angles would be at the circumference. And again, these two angles are equal. Now remember from grade 11 days that this is treated as almost like a bow tie or a butterfly, and the angles in the same segment are equal, or the arcs subtend equal angles. Now what about the cyclic quads? If you look at a cyclic quad, if you remember, what is the important thing here? The opposite angles add up to 180 degrees. So if that is 60, that would be 180 minus 60, which is 120. If that's theta, it's 180 minus theta. These two add up to 180. Now look at this. If this one is, let's say that was 90 degrees, this would be 90 degrees here. The opposite angles add up to 180 degrees. In this case, of course, when you got two right angles, they're equal, but they more specifically add up to 180 because it's not always the case. Remember that the opposite angles, angle B plus angle D, must be 180 degrees. Okay, they're not equal to each other, only if it's 90 degrees. Okay, now what I want to do is I want you to look at another theorem which is theorem 6 actually, but what it does is if you extend that line AB out there, you get an exterior angle. Okay, that exterior angle is going to be equal to the interior opposite angle there. Okay, so just be careful of that. The exterior angle equals the interior opposite angle. Now what I'm going to do is I'm going to go through some conditions that make a quadrilateral become a cyclic quad. And this is very, very important to know. They often ask you to prove that a quadrilateral is cyclic, and you need to know some conditions. So let's focus on those. Okay, what are the conditions that would make a quadrilateral cyclic? Now watch this. You've got a good old quadrilateral here, okay. Alright, A, B, C, D. And you want to prove that it is a cyclic quad. Well, the one thing you can do is look at the opposite angles. So if angle A plus angle C was 180 degrees, or if angle B plus angle D is 180 degrees, if the opposite angles of the quad add up to 180, you can immediately draw a circle around the quad and it becomes a cyclic quad. That's important. Now the other thing that's important as well, if you extend that and you've got an exterior angle, call it C1. If C1 is equal to A, that angle equals that. If the exterior angle is equal to the interior opposite, then the quad ABCD would then obviously be cyclic as well. Now another condition that you can use if you've got a quad, okay, that's very, very important here. If you've got a quad ABCD and inside the quadrilateral, let's just draw these diagonals, and you've got, let's call it A1, A2, D1, D2, B1, B2, C1, C2. If A1 is equal to D1, you've got a bow tie, little butterfly. If A1 is D1, then there's an imaginary circle that can be drawn around ABCD. In other words, if that line BC subtends equal angles, then obviously it must be a cyclic quad ABCD, and it would work for A2 and B2, it would work for B1 and C1, and also for C2 and D2. If any of those conditions hold true, the quadrilateral is cyclic. And likewise, if you've got the opposite angles adding up to 180, or the exterior angle, it could also be down here, look at that, could be this angle is equal to that angle. B1 is equal to D. B1 is D. Then the quadrilateral is cyclic, which means a circle can be drawn around it. And likewise, if the angles in the same segments of the quad are equal, then the quadrilateral is itself a cyclic quad.